Hello friends, today we discuss about the structural analysis. So in that we discuss the finite element method. I, Professor Mrunal Santosh Ugle, Assistant Professor in Kekewag Institute of Engineering, Education and Research, Nasik. So today's discussion topic is finite element method. So in this video we discuss about the introduction, discretization, types of element, isoperimetric and the axisymmetric. So these terms we have to discuss in this lecture. So let us start with the introduction. So what is my finite element method? So the finite element method is a numerical method which gives approximate solution for all complexities of the problem like varying shape, boundary condition and the loads. Then the next point is there, which is the finite element method. So in this we have to discuss about the uh, introduction. Then the finite element method is a numerical method which gives the approximate solution for all the complexities of problems like varying shape, boundary condition and the loads. Obviously, when the regular diagram is there, at that time we can analyze the beam, column or any type of structure with the help of a regular procedure. But when the boundary conditions are different or the shape of the structure is non-linear, at that time we have to go through this finite element method. So it has been used to solve the wide range of problems. Then this includes the linear and non-linear, time independent and dependent problems. Then the finite element is a computation scheme to solve field problem in engineering and science. The fundamental concept involves dividing the body under study into a finite number of pieces called element. The particular assumptions are then made on the variation of the unknown dependent variables across each element using so-called interpolation or the approximation functions. This approximated variation is qualified in terms of solution values at special element called as nodes. So this is the basic information about the finite element method. Then next start with the general principle. So the principle of finite element method is close to the numerical schemes used to solve ordinary differential equation. It consists of approximating the differential operator by replacing the derivatives in the equation using differential quantities. The domain is the partition in space and in time, and approximation of the solution are computed at the space or time point. The error between the numerical solution and the exact solution is determined by the error that is computed by going from the differential operator to a difference operator. This error is called as discretization error or the truncation error. So the term truncation error reflects the fact that a finite part of the Taylor series is used in the approximations. So this is the general principle of the finite element method. So the next term is their discretization. So in this diagram, it is shown that one diagram is there which irregular shape diagram is there which is divided into the number of parts with that these nodes. So at the boundary condition is divided by the nodes. These are the number of nodes are there, and this element we have to analyze which is the finite element. So we can divide this all the element into the number 1, 2, 3 like that, and the nodes are also given the number from this 1, 2, 3, 6 like that. So this is there. So the basic thing, discretization is the process of transferring continuous function, models, variables and the equation into the discrete computer, that is breaking a large problem or the object down into smaller parts that you can then perform mathematically computation on. The discretization of a boundary value problem by the finite element method require the evaluation of the various integral over the element into which the region of the interest is permitted. Even when the function is unknown, it may be necessary to approximate in integral. So this is all about the discretization. So in this discretization, we have to divide the whole structure into the number of elements by the boundary condition is denoted by nodes. So when we have to divide the whole structure into the smaller part, then only you will get the approximate solution of that structure. So next is their assumption in discretization. So in this figure also it is shown that when n is nothing but the number of nodes, this diagram is divided into the 6 nodes, which is also we can simplify into the n is equal to 12 number of nodes, or you can simplify it into the n is equal to 24. So each element we have to analyze with the help of this finite element method, and then only you will get the approximate solution of that problem. So in that assumption, first assumption is there, the elements are attached to the adjacent element only at the nodal point and have a constant material properties. Then second assumption is there, which is the element of a skeletal structure assumed straight and prismatic. The elements of a continuous structure are assumed to have constant thickness. And the last assumption is there, which is nodes are located at the places where abrupt change in geometry. So this is all about the assumptions of the discretization. So next point is there, node. What is meant by node? A node is a coordinate location in a space where the degree of freedom are defined. So in the previous diagram we see here the structure is divided into the number of nodes. Here the 6 nodes are there, here 12 nodes are there, here 24 nodes are there. So according to that, we have to consider a node is a coordinate location in a space where the degree of freedom are defined. Then the degree of freedoms are also represented, which forces and movements are transferred from one element to next. The results of finite element analysis are usually given at the nodes. Nodes and the elements are very backbones of the finite element analysis. Then in finite element analysis, divide your model into the small pieces. So those are called as finite elements, and those elements connect all the characteristic points that lie on the circumferences. So this connection is a set of questions called as shape function. Each finite element has its own set of function that connect all the nodes of the elements. So adjacent elements share common nodes. So this is all about the nodes. Then next point is there, types of nodes. So here main two types of nodes are there, which is external node and the internal node. So here one diagram is shown. Here the external boundary border is there, on that the nodes are there, which is nothing but the external node, and here internal structure is there, which is divided into these nodes. So these are the internal nodes. So with the help of this external node and internal nodes, the structure is divided, and this boundary of this node and the interior structure is nothing but the element. So these are the types of nodes are there. So what is meant by external nodes? So the nodes are occurred on the edge or the surface of the elements, and they may common to two or more than two elements. So in that also primary nodes are there, secondary nodes are there. So in that primary nodes, these are occurs at the end of 1D element and the corner of the 2D or the 3D elements. And the secondary nodes are there, which is these are occur along the side of the element. This is all about the external nodes. So then internal nodes are there. So internal nodes, these nodes occur inside of an element. These are selected to satisfy the geometric isopetry while choosing to satisfy the geometry isotropy while choosing interpolation function. So this is all about the external nodes and the internal nodes. Then next topic is there, which is elements. So what is by elements? So basic things in finite element analysis, it divides model into the small pieces. So these pieces are known as finite elements. So these elements connect all characteristic points called as nodes that lie on their circumferences. So this connection is set of equation called as shape function. The elements fall into the four major categories, in that 2D line element, 2D planar element and 3D solid elements, which are all used to define the geometry, and special element used to apply boundary conditions. For example, special elements might include gap element to satisfy a gap between two pieces of the geometry. So this is all about the elements. So in that also different types of elements are there. So in that one axial element, two axial element, axisymmetric element, three dimensional element. These are the types of elements are there. So in this diagram, it is verify that this 1D element, the name of the element is spring, damper, beam, truss. These are the example of 1D element. So in that 1D element, this is the first order element is there, which is the one dimensional element, and this is the second order element, which is the two dimensional element. This is all about the one dimensional elements. Then next is there two dimensional elements. So in that, these are the surface elements. The example of these 2D elements are shell, plain 2D structure, and here 1D elements are shown here, which is the constant strain triangle and the linear strain triangle. In that case, for the second degree elements is the quadrilateral element or the quadric element. So this is the higher order triangular elements are there. Then third elements are there, which is the volume element. So in that, these are the two example, hexahedral and the tetrahedral, and the diagram of this first order element and the second order element is shown in the figure. So this is all about the types of element. So next point is there, which is the axisymmetric elements. So you know that what is meant by axisymmetric elements. So these elements can be constructed from 1D or 2D element. So an axisymmetric solid of the revolution is defined as the 3D body that is generated by rotating a plane and is most easily described in cylindrical coordinates. So the structure formed by revolving of the surface or revolution of a curve called as axisymmetric structure, where Z is called as axis of the symmetry. If the geometry, support condition, loads and the material properties are all axially symmetric, then the problem can be idealized as a two-dimensional one. So the axisymmetric problem can be analyzed by a finite element of the revolution called as axisymmetric element. So each element consists of a solid ring, the cross section of which is shape of the particular element chosen. So these are the example of this axisymmetric element. So in that also again we can divide any structure with the help of this z axis. So this axis is nothing but the axial symmetry axis. The example is here one structure is there which is divided into the with the help of this z axis, and this small element we have to analyze with the help of this axis. So this is the types of elements are there. In that examples are there, we can analyze the thick cylinder, circular footing on the soil mass, then pile foundation, water tank, cooling towers, chimney, circular shaft. These are the number of examples are there, which is we can divide with the help of this axisymmetric element. So in that also different types of element, 3D elements are there, tetrahedron, hexahedron elements are there. So with the help of that we can study the concept of axisymmetric. So I hope all of you understand the basic concept of the finite element method, then their introduction, then nodes, what is my nodes, what is my elements, then their axisymmetry. So thank you.